All right, so for chemical stoichiometry, practice makes perfect. You want to work through as many of these problems as you have time for. So this chemical equation, we looked at it in class. 6 moles of carbon dioxide gas reacts with 6 moles of liquid water to make 1 mole of C6H12O6, which is a carbohydrate, glucose. And it also makes 6 moles of O2, diatomic oxygen. A little darker. In class, we looked at if we had a certain amount of carbon dioxide, how much glucose could we make? So what I'm going to do is just make a small modification. So let's say we have 100 grams of carbon dioxide. We have an excess of water, so we have more water than we're going to need. And then the question is, how many grams of oxygen can we produce from this chemical reaction? The assumption we are making right now is that this reaction occurs with 100% yield. In the later portion of this chapter, we'll look at what happens when the percent yield is not 100%, how we can calculate that, how we can use it if it's given to us. Off to the side, just to save myself a little bit of time, I wrote down the molar masses of carbon dioxide and oxygen. Usually what you'll find in a problem like this is as you set it up, you'll realize, oh wait, I need this molar mass, or I need that molar mass. So if you can kind of look ahead of what we are given, what we need, for this particular problem, it's pretty obvious we're going to need those molar masses. But it's one of those things that you just kind of pick that up with experience. So 100 grams, 100.0 grams of carbon dioxide in the gas phase will produce how many grams of oxygen? In these particular problems, I will almost always ask you for mass in grams. However, if we were doing a reaction where instead of this was 100 grams, maybe it was 100 tons, then I would most likely ask you for the unit in pounds or tons or something along those lines. But technically, you can convert these into any unit you want. We could convert into grams, we could convert into kilograms, into pounds, and so forth. Grams of CO2, that's what you're given. Grams of oxygen, that's what you want. We can't use gram directly, and the reason why, balanced chemical equations are written in moles. 6 moles of CO2, 6 moles of water, 1 mole of glucose, 6 moles of oxygen. So we have to go from grams to moles before we can do anything else. So the molar mass of carbon dioxide is 44.01 grams CO2, which is equivalent to 1 mole of CO2. I'm putting the phase in there just to be consistent. Grams of CO2 cancel. That's a good sign. Now we have moles of CO2. This is one of the critical things to always make sure that you've got a balanced chemical equation when you start looking at this. 6 moles of CO2 to 6 moles of oxygen. Squeezing that in there so I don't have to erase. CO2 moles cancel. Now we have moles of oxygen. And you can see by inspection, 6 divided by 6 is going to essentially cancel itself out. But don't worry about that until you need to put the numbers in your calculator. Moles of oxygen but we want grams of oxygen. So, again, kind of anticipating where this problem was going, I've got the molar mass of oxygen right there. So 1 mole of oxygen, O2, diatomic oxygen I should say, is equivalent to 32.00 grams of diatomic oxygen. And it is important, in some problems you might be talking about oxygen as a monoatomic species if you were looking for the percentage in a certain molecule. But in this case, we're talking specifically about O2. So I wouldn't put 16, I would put 32. Moles of oxygen cancel. Now I'm in grams of oxygen. So again, we can pick up our calculator and do the math. And this gives .71 grams of oxygen. 4 significant figures. Now, one thing I just went ahead and did it in my calculator because I don't think that fast. I multiplied by 6 and divided by 6. But it is good to just put all the numbers in, even if you can recognize that they're going to cancel out. Or you can save yourself 5 seconds and recognize that. So the maximum amount of oxygen that we can produce from this reaction is 72.71 grams. Again, 100% yield. So this type of problem took us 1, 2, 3 steps, not including calculating the molar masses. Again, dimensional analysis will come to your rescue for this portion of the course, which is going to basically tie in to just about everything else that we're going to do. So get used to using balanced chemical equations and doing mass relationships using dimensional analysis.